In this video, we're going to go over the standard normal distribution, as well as some equations that you need to be familiar with. After that, we're going to work on some problems so you could see how to put these formulas to good use. So the normal distribution has the shape of a bell curve. It looks something like that. Now, the notation for it, perhaps you've seen this in your book. Here's the random variable x. So for a normal distribution, you have two important parameters that you need to know. That is the mean and the standard deviation represented by the symbol sigma. That kind of looks like theta, but there it is. Now the mean is right in the middle of the bell curve. And here this would be one standard deviation from the mean. And over here this will be about one standard deviation away from the mean on the left side. The z-score that corresponds to one standard deviation is simply 1. When x is less than the mean, the z-scores are negative. So 2 standard deviations away from the mean, z is equal to 2. On the left side, z is going to be negative 2. And let's say over here this is 3 standard deviations from the mean. So z is going to be 3. And the same is true for the other side. Now, the formula that you need in order to calculate the z-score is this. Z, that's a terrible looking z, let's do that again. Z is equal to x minus the mean divided by the standard deviation. Sometimes you may need to calculate x. X is equal to the mean plus z times the standard deviation. So these are some formulas that you want to make sure you write down for the problems that I'm going to give you later. The probability density function for a normal distribution is this function here. F of x is equal to 1 divided by the standard deviation times the square root of 2 pi times e raised to the negative 1/2 times x minus the mean divided by the standard deviation squared. And keep in mind, e is a number. It's approximately 2.718 something. Yeah, this continues. Now, in a regular statistics class, you won't need this formula. You just need to know that it is the PDF or the probability density function for the normal distribution. But you really don't need to use it in order to calculate the answer, unless you're using it with calculus or something. It does involve integral calculus to calculate the probabilities with that formula. I've actually did that in another video on YouTube. You could find it. It was probably posted about a year ago or something, if you want to know how to use calculus to get the answer. But for this particular video, we're not going to go into that much detail. But just in case you see a question on a test, at least you know that this formula corresponds to the normal distribution. Now, there's something called the empirical rule that you need to be familiar with. So the empirical rule tells us that 68% of the x values lie within one standard deviation of the mean. 95% of the x values lie within 2 standard deviations of the mean. And 99.7% of the x values lie within 3 standard deviations of the mean. So knowing that, how would you calculate the area under the curve expressed as a percentage in each of these sections? Well, if this area here is 68%, if we divide that by 2, that means this region must be 34%, as well as the left side as well. Now, what is the area in terms of a percent for those two regions? To get that answer, you need to subtract these two numbers. 95 minus 68, that's going to give us 27. And then if you divide that by 2, you're going to get 13.5. Now, it's important to understand that the area of a continuous probability distribution function is 1. So the area of this region is going to be a decimal value. It's 0.135. The same is true for this region here. So keep that in mind. The total area under the curve is equal to 1. Now, what is the probability of finding an x value in those two regions? So what we need to do is subtract those two numbers. 99.7 minus 95, that's going to give us 4.7, and then divide that by 2. So you should get 2.35%. That's the probability of finding or getting an x value in that region. Now, the remaining portions, by the way, this should be like very close to the x-axis. My drawing wasn't perfect. But to find the remaining part, it's going to be 100 minus 99.7, which is 0.3. Divide that by 2. And so there's a 0.15% chance of finding of getting an x value beyond 3 standard deviations. So those are the values when using the empirical rule to solve probability questions relating to the normal distribution. We're going to talk about how to use this chart later in this video. But feel free to write down this information because it's going to be useful shortly. So here's the first example problem that we're going to work on in this video. Now for each of these problems, feel free to pause the video if you want to try it yourself before seeing the answer. And when you want to check your answer, just play the video to see if you got it. So let's begin. So given this information here, what are the values of the mean and standard deviation? So what you need to know is that the first number corresponds to the mean, the second number corresponds to the standard deviation. So the mean is 50 in this example, and the standard deviation is 10. Now, part B. What value of x has a z-score of 1.4? So if z is equal to 1.4, what is the value of x? What do you think we need to do? What formula should we use? So perhaps you wrote down this formula. X is equal to the mean plus z times the standard deviation. So the mean is 50, the z-score is 1.4, and the standard deviation is 10. Now 1.4 times 10 is 14, and 50 plus 14, that's going to give us 64. So this is the answer for part B. So that's how you can calculate x given the value of z. Now what about part C? What is the z-score that corresponds to a value, that corresponds to x equals 30? So if x is 30, what is z? So now we're going to use the rearranged form of that formula. So here it is. The z-score is x minus the mean divided by the standard deviation. So x is 30, the mean is 50, and the standard deviation is 10. So 30 minus 50 is negative 20. 20 divided by 10 is 2. So negative 20 divided by 10 is negative 2. So that's the answer for part C. Now let's move on to part D. What is the difference between positive and negative z values? Let's create a number line, and let's put the mean in the middle. Now, when x was 64, this corresponded to a z value of positive 1.4. And when x was 30, the z-value that it corresponded to was -2. So as you can see, negative z-values are below the mean. They correspond to x values that are below the mean. And positive z-values correspond to x values that are above the mean. And so that's really the difference between positive and negative z-values. The negative z-values are going to be to the left of the mean, and the positive z-values will be towards the right of the mean. Now, let's move on to the next problem. The average test score in a certain statistics class was 74, with a standard deviation of 8. There are 2,000 students in this class. Use the empirical rule to answer the following questions. So, the first thing we're going to do is draw a picture before we begin, because this picture will be very helpful. Okay, maybe I need to draw a better picture. Let's say that's our bell curve. And in the middle somewhere is the mean. The mean is 74. Now this is going to be one standard deviation away from the mean, which is 8. So if we add 74 and 8, this will give us 82. 2 standard deviations away from the mean will be 90. And 3 standard deviations will be 98. Now we're going to do the same for the other side. 74 minus 8 will give us 66. 66 minus 8, that's going to give us 58. And then subtract that by 8 again, you should get 50. So now I'm going to fill in the values that we had before. So we know that this is 34%. So the area under the curve for this region is 0.34. So keep that in mind. Next, we said this was 13.5. And then this area here, that's 2.35. Now the last part is going to be 0.15%. So now we can answer the questions. Let's start with the first one. What percentage of students scored less than 58? So the probability of selecting a student who scored less than 58 is going to be the sum of these two values, because they are to the left of 58. So all we need to do is just add 0.15% plus 2.35%. And that's going to give us 2.5%. So this means that 2.5% of all of the students scored less than 58. So the area under this curve here is 0.025 as a decimal. Now, what about part B? What is the probability that a student scored between 66 and 82 on the exam? Perhaps that question should have been phrased better. Let's say if you randomly selected a student in this class, what is the probability that the student selected would have scored between 66 and 82 on the exam? What would you say? So using a chart, we could find the answer. So all we need to do is add up the percentages between these two numbers. And so it's 34 plus 34. 34 plus 34, that's going to give us 68%. So that's the answer for part B. Now let's move on to part C. how many students scored at most 90? So what's the probability that x is less than or equal to 90? So here's 90. We need everything up to 90. So to get the percentage, we need to add everything in this region, everything below 90. So that's going to be 0.15 plus 2.35 plus 13.5 plus 34 plus 34, and then plus this one as well, 13.5. So the percentage that you should get is 97.5%. So this means that 97.5% of students scored at most 90. Now we're not done yet, but there's another way in which you can get this answer as well. You could say the probability that x is less than or equal to 90 is equal to 1 minus the probability that x is greater than 90. And the calculation for this will be easier. Now, 1 as a percentage is 100%. And the probability that x is greater than 90 is going to be the sum of those values as a percentage. So it's 2.35 plus 0.15%. So if you type that in, you should get the same answer, which is 97.5%. Now, we're not looking for a percentage for our answer, because part C, it asks us how many students scored at most 90. So we're looking for the number of students. And there are 2,000 students in this class, so we need to determine what is 97.5% of 2,000. 97.5% as a decimal is 0.975. To get that number, just take the percentage divided by 100. 2,000 times 0.975, that's 1950. So this is the answer for part C. So 1950 students scored at most 90. Now let's move on to part D. What percentage of students scored at least 66? Go ahead and try that. So let's determine the probability that x is at least 66, which means it could be 66 or more. So it's greater than or equal to 66. So therefore, we need everything to the right of 66. So we're going to add 34% plus another 34% plus 13.5%, and then 2.35% plus 0.15%. So the answer is going to be 84%. That's it for part E. I mean, not E, part D. Part E, how many students scored more than 98 on the test? So what is the probability that x is greater than 98? So the only thing above 98 is 0.15%. Now once again, we're looking for the number of students. So we got to find out what 0.15% of 2,000 is. So first, let's convert this into a decimal. As we said before, to change a percentage into a decimal, divide by 100. So 0.15 divided by 100 is 0.0015. So what we need to do is multiply 2,000 by that number. 2,000 times 0.0015, that's going to give us 3. So about 3 students scored more than 98 on the exam. And that's it for number 2. So that's how you could use the empirical rule to answer probability problems related to a normal distribution situation. Now, sometimes you have z-scores that are not whole numbers of the standard deviation, and you can't use the empirical rule. Whenever you have z-scores like 1, 2, 3, or -2, -1, you could use the empirical rule to calculate the area under the curve, just calculating the probability in question. But let's say if your z-score is 1.56, you can't use the empirical rule to calculate the area under the curve. And if you don't want to use integral calculus, you need to use the standard z-tables, sometimes referred to as the normal distribution tables. Now I'm going to show you how to use it real quick, but let me talk about the graph. So here is our standard normal distribution. Let's say this is the mean. And let's say this is the z-score of 1.56. So when you get the area under the curve from the z-table, which for this problem, it's going to be 0.94062, you need to understand that this gives you the area to the left of that line. Let me put this line in red. So it gives you the left side, the area of the shaded region in blue. Let's say if your z-score is negative, let's say z is negative 0.43. Using a table, you'll find that the area to the left is 0.33360. And so the graph, if you wish to shade the region, will look something like this. Here's the mean. Z is negative, so it's going to be to the left of the mean. So it's going to be to the left of the dotted line. So that shaded region corresponds to an area of 0.3336, which means if you want to convert that to a percentage, the probability that X lies in this region somewhere will be 33.36%. You just need to multiply that by 100. So here we have a positive z-score table. So the first thing we're going to do is look at the first column and find the value that corresponds to 1.5. Now looking at the first row, we need to find the value that corresponds to 0.06, because 1.5 plus 0.06 gives us the z-score that we want, 1.56. Now we need to find the number that corresponds to the row 1.5 and the column 0.06. And as you can see, that number is 0.94062. So that represents the area under the curve given a z-value of 1.56. So the area of the blue region shaded to the left, the area under the curve, that's going to be 0.94062. So that's how you could find it using the positive z-score table. Now the next z-score value that we're looking for is negative 0.43. So in the first column, we see the value negative 0.4, and in the first row, we need to look for the column that says 0.03. So the value that corresponds to a z-value of negative 0.43 is 0.33360. That is going to be the area under the curve given a z-value of negative 0.43. So that's how you could find the area under the curve if you know the z-score. You just got to look it up in the table and you'll get the answer. Number 3, normally distributed IQ scores have a mean of 100 and a standard deviation of 15. Use the standard z-table to answer the following questions. What is the probability of randomly selecting someone with an IQ score that is less than 80? So let's write down what we know. The mean is 100 and the standard deviation is 15. Now let's draw a picture. So here is a rough sketch of our bell curve. The mean is 100, and we want to find the probability of selecting someone with a score of less than 80. So what we need is the area to the left of 80. So the first thing we need to do is calculate the z-score, and then we could use the z-table to get the area under the curve. So we know that z is going to be x minus the mean divided by the standard deviation. So x is 80 based on this problem. We're trying to find a probability that x is less than 80. So we're going to say x is 80. The mean is 100 and the standard deviation is 15. So 80 minus 100 is negative 20. Negative 20 divided by 15 is negative 1.33. Now it's negative 1.3 repeated, but we're going to stop it at negative 1.33. So what you need to do at this point is use the negative z-table and find the area, the value of the area that corresponds to the z value. So using that table, you should get 0.09176. Now that's the answer as a decimal. If we multiply this by 100, we'll get the answer as a percentage, which is 9.176%. So that is the probability of selecting someone with an IQ score less than 80. Now let's move on to part B. What is the probability of randomly selecting someone with an IQ score that is greater than 136? Go ahead and try that. So first, let's begin by calculating the z-score. It's going to be x minus the mean over the standard deviation. So that's 136 minus 100 divided by 15. So 136 minus 100 is 36, and 36 divided by 15 is 2.4. So using the positive z-score table, convert the z value of 2.4 to the area value. So find the area under the curve that corresponds to a z-score of 2.4. Go ahead and take a minute to do that. So the value that you should get is 0.9918, but that's not our answer yet. We're on the right track, but there's a little more work that we need to do. So let's draw a picture. So here is the mean of 100, and here is our x value of 136, which corresponds to a z-score of 2.4. Now, we want to find the probability that x is greater than 136, which is this region. The z-score table, the positive z-score table, it gives us the area to the left. So that is the area highlighted in red. So that area is 0.9918. We want to find the area highlighted in blue. Keep in mind the total area is 1. So the probability that x is greater than 136 is going to be 1 minus the probability that x is less than 136. Or you could say less than or equal to. So this answer that we have here, that corresponds to the probability that x is either less than 136 or less than or equal to, because it's going to be the same. So the answer is 1 minus 0.9918. And that's going to be 0.0082. So there is an 8.2, or rather, there is a 0.82% chance that a person selected at random will have an IQ score that's more than 136. So this is the answer to part B. Part C. What is the probability of randomly selecting someone with an IQ score that is between 95 and 110? So what do you think we need to do for that problem? Well, let's begin by drawing a picture, just to get a good visual of what we need to do. So we need to calculate the area of this region highlighted in blue between 95 and 110. In order to do that, in order to calculate the probability that x is between 95 and 110, we need to take the difference of the probability that x is less than 110 and the probability that x is less than 95. The probability that x is less than 110 looks like this. Here's the shaded region that corresponds to it. And we need to subtract that region by what we have here. So if we take the region shaded in red, subtracted by this region, it will give us the area under the curve between 95 and 110. So that's what we need to do in this problem. But we need to calculate the z-scores that correspond to those two numbers first. So z is x minus the mean over the standard deviation. So let's start with an x value of 110. And so this is going to be 110 minus 100, which is 10, and 10 divided by 15. This is 0.6 repeating, but we're going to round that to 0.67. Now when x is 95, this is going to be 95 over, or minus 100, which is negative 5. And negative 5 divided by 15, that's negative 0.3 repeating. But we're going to use negative 0.33. So the area that corresponds to a z-score of positive 0.67 using the positive z-score table, that is 0.74857. And the area that corresponds to a z-score of negative 0.33 using the negative z-score table, that's positive 0.37070. So this value corresponds to the probability that x is less than 110, and this value corresponds to the probability that x is less than 95. So let's go ahead and subtract these two values. .74857 minus 0.3707, that's going to be 0.37787. So that is the area under the curve between the x values 95 and 110. So we could say there is a 37.787% chance that a randomly selected person will have an IQ between 95 and 110. Now, what about part D? What IQ score corresponds to the 90th percentile? Go ahead and try that problem. Let's begin by drawing a picture. We have drawn many pictures in this video so far. So here is the mean. The mean is at the 50th percentile. This is 0, this is 100. So the 90th percentile would be somewhere in that area approximately. And there is an x value that corresponds to the 90th percentile. We need to determine what that x value is. Now, what we know is that the area to the left of that x value is based on the percentile. If the percentile is 90, the area to the left has to correspond to 0.90. And so using the z-table, we can kind of work backwards in reverse here. We can take that area and find the z-score that corresponds to it. So find the z-score that corresponds to an area of 0.90. We need to use the positive z-table because the area is greater than 0.5. Now there's two values of interest. A z-score of positive 1.28 has an area of 0.89973. And a z-score of 1.29 has an area to the left of 0.90147. Now this value is a lot closer to 0.9 than is this value. It's about 5 times as close. If you take the difference between this number and 0.9, you're going to see that it's a lot smaller than the difference between this number and 0.9. So I'm going to choose a z-score of 1.28. So now that I have the z-score that corresponds to the 90th percentile, I can calculate the x value using this formula. X is going to be the mean plus z times the standard deviation. So the mean is 100, z is 1.28, and the standard deviation is 15. So go ahead and type that in. The answer that you should have is 119.2. So this is the IQ score that corresponds to the 90th percentile. Part E. The middle 30% of IQs fall between what two values? So what do you think we need to do to get that answer? Part E is very similar to Part D. Let me show you why. So let's put the mean here. So this is going to be 100. And we're going to call this value x2 and this one x1. Those are going to be the two IQ values that we're looking for. Now granted, it's not drawn to scale. So this is going to be the middle 30%, which means that 15% will be on the right side and 15% will be on the left side. So we need to we need to find the x values that correspond to these percentages. Now understand that this is the 50th percentile, so 15% to the right of that will bring us to the 65th percentile, and 50 minus 15 on the left will give us the 35th percentile. So we need to find the x value that corresponds to the 35th percentile and the x value that corresponds to the 65th percentile. So that's how it's similar to Part D. So let's start with the 65th percentile. That means the area to the left, that is everything from here. If you shade if you find the area under the curve, all of this will have an area of 0.65. So now, using the positive z-table, what z-score corresponds to an area of 0.65? What would you say? Now there's two values of interest. When z is 0.38, the area is 0.641. 0.803. It's pretty close to 0.65. And when z is 0.39, the area is going to be 0.65173. So these two values are almost equidistant from 0.65. Therefore, if we average them, we'll get a number close to 0.65. So I'm going to take the average of those z-scores. So I'm going to choose a z-score value of 0.385 because 0.65 is in the middle of these two numbers. So now let's get rid of this. So the z-score that corresponds to x2 is 0.385. Now, due to the symmetry of these percentiles, the z-score that corresponds to x1 is negative 0.385. And you could check that out. If you look up an area value of 0.35, which corresponds to the 35th percentile, you'll get a z-score of negative 0.385 using the negative z-score table. So now that we have the z-scores, what we need to do is calculate the x values. So let's start with x2. This is going to be z2 and this is z1. So x2 is going to be the mean plus z2 times the standard deviation. So that's 100 plus positive 0.385 times 15. And so x2 is 105.8 if you round it. The exact answer that I got in my calculator is 105.775. Now, for x1, we're going to use the same formula, but using z1 instead of z2. So it's 100 plus negative 0.385 times 15. So x1 is going to be 94.225, but I'm going to round that to 94.2. So these are the two x values that correspond to the middle 30% of all the IQs based on the standard normal distribution. So that's it for number 3. Now let's move on to number 4. Company XYZ manufactures an average of 400,000 tires annually. On average, 2% of the tires were manufactured with a defect. A random sample of 500 tires were selected for quality control. Part A. Calculate the mean and standard deviation of the defective tires in the sample. So take a minute to work on this problem. The first thing that we want to take into account is that 2% of the tires have a defect. So the probability of getting a tire with a defect is 0.02. The probability of not getting a tire with a defect, that's going to be Q, that's 1 minus 0.02, which is 0.98. Now, we're choosing a sample size of 500 tires, so N is 500. So we're choosing a small sample out of the 400,000 tires that are manufactured annually. Now, to calculate the mean in this situation, we could use this formula. It's going to be N times P. So it's 500 times 0.02. So basically, we're looking for 2% of 500. 0.02 times 500 is 10. So about 10 of the 500 tires on average will have a defect. So that is the mean. Now let's calculate the standard deviation. The formula that we're going to use is this one. It's the square root of N times P times Q. So N is 500. P is 0.02, and then Q is 0.98. So this is going to be 3.13. So that is the standard deviation in this problem. So that's it for part A. Now part B, what is the probability that less than 8 tires will be defective in the sample? First, let's rewrite the mean and the standard deviation so I can create more available space. So we're looking for the probability that x is less than 8. So we need to use the z-table, but first we need to calculate the z-score. So z is going to be x minus the mean divided by the standard deviation. X is 8, the mean is 10, and the standard deviation is 3.13. So 8 minus 10 is negative 2. Divide that by 3.13. This will give us a z-score of approximately, if we round it, to negative 0.64. So now, using the negative z-table, we need to get the area under the curve to the left. So negative 0.64 corresponds to an area value of 0.26109. So we could say that the probability that less than 8 tires will be defective in the sample is 26.1% approximately. That's a rounded answer. So that's it for part A. I mean, not part A, but part B. Now let's move on to part C. What is the probability that more than 15 tires will have some sort of defect? So let's calculate the probability that x will be greater than 15. So once again, let's calculate the z-score first. So this is going to be 15 minus 10 divided by 3.13. So that's 5 divided by 3.13. And so that's 1.597, but we're going to round it to 1.6. So that's the z-score. Now, using the positive z-table, 1.6 corresponds to an area of 0.94520 from the left. Now, if we draw the picture, we want the area on the right. So here's the mean. Let's say this is 15. The area shaded in blue corresponds to this value, but we want the area shaded in red. So it's going to be 1 minus this answer. So it's 1 minus 0.9452. And so that's 0.0548. So that corresponds to 5.48 as a percentage. So there's a 5.48% chance that more than 15 tires will have some sort of a defect. Now let's move on to part D. What is the probability that the number of defective tires will be between 7 and 14? So what is the probability that x is between 7 and 14? So this is going to be the probability that x is less than 14 minus the probability that x is less than 7. So let's calculate the z-scores for both numbers. Let's start with 14. So it's 14 minus the mean of 10 divided by 3.13. So that's 4 divided by 3.13, and that's going to give us a z-score, if we round it, to 1.28. Now using the positive z-table, 1.28 corresponds to a value of 0.89973. Now let's calculate the z-score when x is 7. So 7 minus 10 is negative 3. Negative 3 divided by 3.13, that's going to be We got to round this to negative 0.96 using the negative z-table. Negative 0.96 corresponds to a value of 0.16853. So the area under the curve from the left to x equals 14 is 0.89973. And the probability that x is less than 7 is going to be 0.16853. So we got to take the difference of those two values, and that's going to give us this answer, 0.7312. So the probability that the number of defective tires will be between 7 and 14 is 73.12%. And that is it. So that's it for this video. If you found it to be helpful, don't forget to subscribe to this channel if you want more videos like this. Thanks again for watching.